Hello friends, welcome back to my YouTube channel. So in today's video we will start the new chapter, that is flexibility method. So this is also called as the force method or compatibility method. So first we will see the what is mean by flexibility. So flexibility means ability to deform under an applied load or displacement caused due to unit load. So it means when we applied the load, the structure which changes its shape, it's called the flexibility. So this occurs when we applied the load. The structure will change its originality or its shape. It's called the flexibility. So now we will see the generating the flexibility matrix. So this is the formula. Delta is equal to F11, F12, F13 and F21, F22, F23 and F31, F32, F33. So here we'll see. So to find out the F11, and we have the formula for diagonal elements. So F11, F22 and F33. So we have the formula. So F11 is equal to find out the F1 we have the formula integration of 0 to L into M1 square divided by EI into dx. So here EI is constant and M1 means bending moment. So I will tell you later what is M1 and how to find the M1. And here F22 is equal to, for that we have the formula integration of 0 to L into M2 square divided by EI into delta x. And similarly for F33 is equal to integration of 0 to L into M3 square divided by EI into dx. Here EI is constant. So M1, M2, M3, how to find this I will tell you. So assume a structure. So this is the structure. So this is the main structure. The main structure is called as, it is denoted as capital M. So which is given in question. So which is given in question, it is called as capital M. So now see here, when if they ask to, so now I will give the name to this. So if they ask to find the rotation at point C, so then we need to apply at point C unit rotation. I will show you here. So this is our given. So given problem. If they ask to find the rotation at point C, then we need to apply the unit rotation at point C, 1 kilonewton, that is 1 kilonewton. So this structure becomes our M1. So which we have redrawn, the diagram which we have redrawn, this is called the M1. So if they ask to apply the unit load at point B, so then we need to find like this. So I have applied the 1 kilonewton of unit load at point B. So this structure will, so it is called M2. Call it as M2. And if they ask to apply the, so when they ask to apply the horizontal deflection at point C, so then we need to apply horizontal unit load like this. So the diagram will call the M3. So this is M3. So this is the possible way of, they may ask whether to find out the moment or horizontal load and vertical load. So this is M1 and M2, M1, M2 and M3. This is how we need to find. So now we'll see. So here we have known the how to find the diagonal elements by using this formula, and we also know the how to find the M1, M2 and M3. So now we'll see the how to find the F21 and F12. So here the formula for finding the F21 and F12 will be same. So F12 is equal to F21 is equal to integration of 0 to L. So M1 into M2 divided by EI into dx. How to take M1 and M2 means, see here we are taking the F12. 12 means we need to take the moment of your first point, and here also moment of first point. Here first point is 2, no? Here first point is 1, no? We need to take the moment of these 2 points, or otherwise you can take the moment of these two. first point and second point, and both will be same. Here one means moment of here m1 means moment of first point and m2 means moment of second points. You can multiply it, both will come in the same. You can take this way or that way. And here similarly for f13 and f31 we have the same formula. Integration of 0 to L into here first point is 1 and second point is 3. So we need to take the moment of these two. So m1 into m3 divided by ei into dx. And similarly for f23 is equal to f32, we have the formula 0 integration of 0 to L m2 m3 divided by ei into dx. So here also our first point is 2 and second point is 3. We need to take the moment of these two, or here first point is 3 and second point is 2. You need to take moment of these two, the both will be same. m2 into m3 divided by ei into dx. So by using this formula you can calculate the flexibility matrix, and this is how we need to generate the flexibility matrix by using this formula. So next we need to see what is the working procedure of flexibility. Step 1 is to find out the degree of static indeterminacy ds. So I have already made the separate video for static indeterminacy, how to find this. So you can go through that video. I'll give the link in the description box. You can watch that video before seeing this video. So I already explained in details. So what is determinate structures and indeterminate structures and static indeterminacy. So I will give the link in description box. You can go through that video. So now we'll see the step number 2 is select the redundant forces and remove them to make a structure statically determinate. So redundant means, so now I will tell you what is mean by redundant. Now we'll see. So this is the given structure. So here the possible reactions are, one is horizontal and vertical and one moment. Here also 3 possible is reactions is 3. So how many reaction? Total reactions are 6. So how many equilibrium equations are there? 3. Equilibrium equations are 3. So to find out the ds, we have the formula r minus e. So 6 minus 3 will come out as 3. So 3 means we have the redundant 3. So we have the 3 numbers of redundants. So to remove these redundants we need to, so now the structure is unstable, indeterminate. To make it determinate, so what to do is, see here. So here the reactions are 3. So reactions are 3, equilibrium equations are 3. So now ds is 0. So now ds is 0 means our structure is now stable. To make it stable we need to remove these 3 redundants from this. So now this structure becomes statically determinate structure. Statically determinate structure. So when our ds is here, so when our ds is equal to 0, so our structure is statically determinate. It means it is stable. So when our structure is greater than 0, our structure is statically indeterminate or unstable. Here our ds is greater than 0, ds is 0, it means it is statically indeterminate structures compared to this statically indeterminate structure. So when our ds is equal to 0, our structure is determinate, it means it is stable. So to make it stable we need to remove these 3 redundant. And the one more condition is there. So our structure is statically unstable when our ds is less than 0. So less than 0 means, I will show you when it is unstable. So this is the structure. So the reaction is only vertical reaction is takes place. Here also vertical will takes place. So total number of reactions are 2 and our equilibrium equation is 3. So our ds is equal to r minus e. It means 2 minus 3. 2 minus 3 means will come out as minus 1. So minus 1 means our structure is unstable when our ds is less than 0, 0 means it is -1, less than 0 structure is unstable. See here. So this I have already explained in our while explaining the static indeterminacy. I will give link in the description box, you can go through that video. So our third step is to assign the coordinate to the redundant. So redundant means our 3 means the one is horizontal, one is vertical, one is moment. So giving name to these. So for moment I am giving 1, for this I am giving number 2, for this I am giving number 2. So giving name to this redundant. So this is our step number 3. And step number 4 is to calculation of the displacement at the redundant coordinates due to the external load. So it is denoted as dou L. So while analyzing the problem, I will tell in detail. So how to find the displacement. So our step number 5 is to calculation of the displacement redundant at coordinates due to the redundant. So it is denoted as dou R. And our step number 6 is to find out the net displacement. So by adding these two, we need to find the net displacement. So after find out net displacement, we'll go for the, so by using the compatibility of condition of compatibility of displacement to find out the redundance. So formula is, by using this formula we need to find the P matrix. So here inverse, or we need to do the inverse of delta we need to take. So it means the flexibility matrix. So here dou L means displacement matrix, which we have find out here. So while analyzing I will tell you in details. So our next step is to find out the unknowns by static equations. By using the static equations we need to find the unknowns. So the possible equations are summation of fx and summation of fy and summation of all the moment is equal to 0. By using these two equations we need to find the unknowns. And our last step is to drawing of the SFT and BMD. So this is our last step. So this is the working procedure of the flexibility method. So while analyzing I will tell in details how to find the problem by using the flexibility method. So this is the working procedure of flexibility method. So in next video we will solve a problem, we'll take the problems on this method. So here, if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.